Hello and welcome back to our course. So in the last session we learned that ND arrays are containers of homogeneous data, so in particular for numerical data, and this allows us to make fast element-wise and vectorized operations. So far we have only seen one-dimensional arrays, or only one sequence of elements, and in linear algebra you would call it a vector. And this is only a special case of ND arrays. And the general case is a multi-dimensional array. And in the case of 2 dimensions, in linear algebra we would call it a matrix. And a matrix has rows and columns. And the amount of elements in a row, so if we count the number of elements from left to right, is the size of a row. And the amount of elements in a column, so we count the elements from top to the bottom, is the size of the column. And the size of each of those dimensions give us the shape. So for example, we have 3 rows and 4 columns. But now let's start coding. So we import Numpy as NP as always. And then we create a Numpy array from 1 to 12 including. And we can check the type. So it should be an ND array. And then we can check the shape of our ND array. So by calling the attribute shape. And here you can see it's a one-dimensional array, so we have only one dimension here. If we had 2 or 3 dimensions, we would have 2 or 3 numbers here. It's a one-dimensional array containing of 12 elements. In linear algebra, you would call it a vector with 12 elements. And what we now can do, we can reshape our ND array A with the method .reshape, and then we can determine how the shape should look like. The first position determines the amount of rows, and the second position determines the amount of columns. Here we want to transform our one-dimensional array with 12 elements into an array with 2 rows, and each row has 6 columns. So let's run the cell, and let's have a look at A. So here you can see Python returns us a 2-dimensional array. So we have here an outer array, and this is containing 2 arrays, so 2 rows here in this example. So we have the first row and the second row, and each row has 6 columns. And we can also check now the shape of our new 2-dimensional array. And it's no surprise, 2 and 6, so 2 rows, 6 columns. Of course, we can also reshape our array to the shape 6 rows and 2 columns. Also here with the reshape method. So now you can see we get 6 rows and each row containing 2 elements. So we have 6 rows and 2 columns. And let's also check the shape. It's 6 rows and 2 columns. And element-wise operations or vectorized operations still work in the same manner as with only a one-dimensional array, so that's no problem. So if we add 100 to A, we add 100 to each element of our array. So before we had here 1, 2 in the first row, now we have 101 and 102 and so on. So now let's remind that we have in total 12 elements in our array. And if we try to reshape our array, let's say into 3 rows and 5 columns, so that would mean 15 elements, this does not work. And Python says here cannot reshape array of size 12 into shape 5. And we are not limited to 2 dimensions, so we can increase the amount of dimensions to, let's say, 3. So we can say, okay, we want to reshape the ND array A and create a 3-dimensional array. So the first dimension has the size of 2, the second has the size of 2, and the third dimension has the size of 3. So it's kind of a cube. So now you can see here, this is the first element of the first dimension, and this is the second element of the first dimension. So the first dimension contains 2 times a matrix consisting of 2 rows and 3 columns. So let's check the shape of A. And we get the shape is 3-dimensional with the size 2, 2 and 3. So now let's assume we want to create a 2-dimensional array containing of the numbers 1 till 100 including in a shape 25 rows and 4 columns. We can do that in 1 line of code. So first of all we create a one-dimensional array consisting of the numbers 1 till 100, and then we reshape the array and get 25 rows and 4 columns. So let's see what we get. So now we have here 25 rows and 4 columns. And our elements are numerated from 1 till 100. Alright, so this was the introduction to multi-dimensional arrays, and yeah, in the next session we will have a look how to index and slice multi-dimensional arrays. So hope you enjoyed it, and see you in the next session. Bye!